Hi ladies and gentlemen, so today we're taking a look at 5.4 part 2, continuing with graphing these rational functions. So you'll notice that there's a repeat of these boxes that were in the first part of 5.4's lesson. We have the first type of rational function, which is in this form where you have a fraction and then you have a number added or subtracted after the fraction. The second form is where you have just the strictly two polynomials being divided together. So for a warm-up, let's review some of the things we talked about in the first part of this lesson. So identifying the asymptotes in the domain and range. So our vertical asymptote is in the form of x equals, and it takes that denominator, solving it for x, we would get negative 10. That also identifies for us our domain, which is all real numbers, except x is not allowed, all real numbers, except x is not allowed to equal negative 10 because that's where the asymptote is. Again, you don't have to write it in this super mathy way. You can write it out in words saying, all real numbers except x cannot equal negative 10, and that would be fine. My horizontal asymptote, which is an equation in the form of y equals, and it's y equals the k value that's on the end here. So that would be a positive 19. That then tells me my range is all real, and we wouldn't say x, we would say y, because we're talking about range. So y can be any real number except y is not allowed to equal 19 because that is where a vertical or a horizontal asymptote, lives. So this is what we went over in the first part. The other type of problem we went over in the first part of this lesson was finding zeros and asymptotes of functions that are in this form where you have a polynomial divided by another polynomial. So if we take a look at this, the first thing we want to do, x squared plus 2x minus 15, we want to factor that into x plus 5 and x minus 3. Then the denominator is still x minus 1. That can't be factored. Our zeros, as we learned in the first part of this lesson, come from taking the numerator and solving it for x. So we have two zeros, one at negative 5 and one at positive 3. The next thing we're going to take a look at are the vertical asymptotes. We've not talked about horizontal asymptotes with rational functions in this form yet, just the vertical ones. So the vertical asymptote comes from the denominator and solving that for x. So it would be at x equals 1. Now let's take a look at finding horizontal asymptotes for rational functions that are in this form where we have one polynomial divided by another. And we have three options for these horizontal asymptotes. So the first, and it's all based upon degrees, which degrees are defined by the highest exponent within the polynomial. So if your degree of the numerator, because that's what p is, if the degree of your numerator is larger than your degree of the denominator, then there's no horizontal asymptote. If the numerator is smaller than the denominator, then the asymptote is at y equals 0. And if they are equal to one another, you would divide their leading coefficients. So let's go through some examples of these. Looking at the first one, we want to identify the zeros and asymptotes, both vertical and horizontal asymptotes of the function. So first thing we should always do whenever we're looking at any of these rational functions is get everything in factored form. So x squared minus 9x plus 14 will factor into x minus 7 and x minus 2. The denominator is still going to end up being x plus 5. Finding our zeros, as we already talked about since the last lesson, is by solving that numerator for x. So we would get zeros at positive 7 and positive 2. And again, that is coming from solving the numerator. That's how we're getting the zeros. Now we're going to identify our vertical asymptotes. Vertical asymptote is coming from solving the denominator for x, so that would be negative 5. So x plus 5, solving that for x is going to give me my vertical asymptote, or my vertical line that would divide the graph up, and that would be at negative 5. The last thing we're going to define now is the horizontal asymptote, which is the newest thing. And I'm shorthanding horizontal asymptote and vertical asymptote as HA and VA. what we're going to do here is we need to look at the degree of our numerator and denominator. The degree of our numerator, the highest exponent, is a 2. The degree of our denominator is 1 because this x in the denominator is x to the power of 1. The numerator is a larger degree than the denominator because 2 is bigger than 1. And if we think back to this table here, when the numerator is larger than the denominator, which is what we're seeing here, we would say that there is no horizontal asymptote. So here, we're going to say that there is none, and that is because degree of the numerator is larger than the denominator. All right, perfect. So let's take a look at example 3. Similar setup, identify the zeros and asymptotes, vertical and horizontal, of the function. This one we don't have to worry about factoring at first like we did with the other ones because they're both linear. All right, so our zeros is taking that numerator and solving for x. We can't put this in factored form and just take the opposite, so we actually have to do a little bit of work here. So I'm going to take the 4x minus 12, set it equal to 0, solve for x. I would first add the 12 over to give me 4x equals 12. Then I would divide by the 4 and I would get x equals 3. So my zeros, there's only one of them and it's at x equals 3. My vertical asymptote, which is found by solving the denominator for x, my denominator is x minus 1. Solving that for x, I would get x equals positive 1. The horizontal asymptote, which is found by looking at the degrees of your numerator and denominator. The degree of my numerator is 1 because that x is to the power of 1. The denominator is also 1 because it's x to the power of 1. So notice that my numerator and denominator degrees are the same. When that happens, if we look back at this slide, when they're the same, you're going to divide your leading coefficients of the top and bottom of the fraction. So my leading coefficient of the top of this fraction is 4. My leading coefficient of the bottom of the fraction is 1. So I'm going to end up with this equation of y equals 4 over 1, or you could say y equals 4. Oops, here we go. And that's going to be your horizontal asymptote.